I wanted to create a variable lab bench power supply that must be more powerful. So I searched Google on a powerful buck converter and found out the Xl4016. After spending the next 10 minutes looking through the datasheet of the IC, I wanted to verify the maximum power it's rated for and also the efficiency of it. And well, these ratings seem a bit crazy, like 8 amps and a maximum efficiency of 95%. So in this video, let's test this converter. Actually, I have made the power supply. I also added an OSKJ 150 watt boost converter to the input of the buck converter. So let's test both of them together with the syringe needle as a load and make it glow red. Let's get started up. So right now the power supply is set to 5 volts and let's crank up the current. Now it's 8 amps. Let's try a bit more current and my power supply trips due to overcurrent, which is obvious because it's rated for just 5 amps. So the input power is 15 volts multiplied by 5.3 amps. The output power is 5 volts and 8.3 amps. And the input power is 79.5 watts. The output on the other hand is 42.5 watts. And the efficiency equals power out divided by power in, which is 42.5 watts divided by 79.5 watts. And we need percentage, so we need to multiply it by 100. And it's 53.45%. That's terrible. Part of the reason might be the fact that the power supply draws 0.68 amps when idle for the inbuilt fans, which equal 10.2 watts, and the fact that there's an additional fan that runs with the SMPS. And also there's my other lab bench power supply, which sum up to a maximum of 1 amp altogether. So after subtracting 15 watts from 79.5 watts, which equals 64.5 watts, and doing the efficiency math again, we get an efficiency of 65.89% at 5 volts. Now let's test it with 12 volts and see if it does better. Now keep in mind, this test load isn't a short circuit because there is some voltage drop on the needle. And exactly on 8 amps, the overcurrent protection kicks in again. So, the input power is 79.5 watts and the output power is 96 watts. And the efficiency is 96 divided by 79.5 multiplied by 100. Well, actually the input power is 64.5 watts by tolerating the idle power. And the efficiency turned out to be 148.83%. Now let's try it with 24 volts. And at 8 amps, the input current is 5 amps. And my overcurrent protection is ready to kick in at any moment. So, the input power is 15 volts multiplied by 5 amps. And the output power is 24 volts times 8.3 amps. Subtracting 15 watts from the input power, which is 60 watts, and the output power is a whopping 199.2 watts. That's a lot. The efficiency is 199.2 watts divided by 60 watts and multiplying it by 100. And that is a whopping 332% efficiency, which seems kind of fake, But yeah, you've just seen the tests. Here's the table chart that shows the tested voltage, power in, power out, and efficiency. I hope you have enjoyed this video. Stay tick and I will see you next time.